Hello everyone, welcome back to the good stuff we've been doing. In the previous video, we learned how to multiply out terms such as say 2x cubed minus x squared plus x, or let's say 2x then plus 1, and then we'll have x squared minus x plus 1. We say that here we simply arrange the terms here based on 2, negative 1, 2, 1, and then we have here 1, negative 1, 1, and then we multiply just like we described before. This method is called the method of detached coefficients, but then it only works when the terms are nice. Like instead of after x cube we should have x square, and after x square we should have just a single x here. But what if there's always a question like, what if they give us something like this 2x cube with this minus x, and then we'll have plus 1, and then we'll have x square minus x plus 1. The question arises, how do we treat this term here? How do we arrange it? And the problem is that we cannot really arrange it this way. We cannot really write 2, negative 1 and 1, then write 1, negative 1 and 1. We will not get a correct result if we do this. But then the term in x square is not really missing. It's present, just that we cannot see it. So the reason we cannot see it is that we have not washed our face. So let's take the bowl and wash our face very well, and then we write this as 2x cubed. Then we write plus 0 x squared minus x plus 1. So with this method now, we see that 0 is actually present, it's a number, it's a valid number. So we just fix the 0 back, and then we pick this x squared minus x plus 1. So there is nothing giving 0 any 0 has all the right to be present here. It's not less of a number. It's the way 2 is a number, that's the same way 0 is a number. 2 does not have more right than 0. So when we fix it, we can fix 2, 0, negative 1, 1, and then 1, negative 1, 1, and then do the usual multiplication, which we shall see in the next example. So for this part here, we are asked to multiply out these terms here, where here the power of x cube is missing here, which we know how to fix. We can simply write it as, if we arrange it, we have x to the fourth plus 0x cubed minus 2x squared plus, and the power of x is missing as well, I think. So we have 0x as well. They'll have a plus 1 here. Here we have x to the fourth, right? Then you have plus 0x cubed plus 2x squared. Then we have a plus 0x here, and they have a plus 1 here. So everything has been fixed. Now how do we start? We just write down the coefficient. Since we are detaching the coefficient, we have a 1, we have a 0, we have a negative 2, we have a 0, and have a 1 here. Or for the same reason as well, we have a 1, we have a 0, we have a 2, and then we have a 0, and then a 1. And then the detached coefficient method there, what we will do here, I'll have to shrink this a bit. Okay. So what we'll do here is to come as follows. 1, we have to multiply out all the terms above here. So 1 going with 1 is 1, going with 0 is 0, with negative 2 is negative 2, with 0 is still 0, and then we'll have a 1 here finally. If 0 goes the journey, we'll have a, there's no point in really writing out the 0 part, but we'll still do it. We'll have a 0, we'll do it, but we'll not look at the board as we're doing it. So like we'll not multiply it out. This is because there's no point in writing the part where 0 contains here, because everything boils down to 0. Now nothing again. For the 2 case, for the 2 we have a 2 here. We have a, of course, have a 0 here last. We have a 0 here, and then we'll have a negative 4 here. Then we'll have a 0 here, and then we'll have a 2 here. What we'll have next is for the 0 case, and see there is no point in writing out the 0 cases here, but we will still do it. So I will just mark this part. You can ignore this part. Then after the 0 case, we continue with the 1 case. One, just put everything down there. 1, 0. 1 is like a mirror in multiplication. Negative 2, 0, and then 1. So all that remains now is to add these terms we have managed to work out. So here we have 1, 0. We don't add the 0 out. You have 0 0. So let's still do it. Let's still write the 0 out. Let's see this 2, this negative 2, I think. Yeah. So negative 2. Here we have the 0. We have the 0. Wow. We have the 0. We have the 0. So if we arrange this part will correspond to x to the power of 0, x to the power of 1, and then this is 2, 3, 4, 5, 6, 7, 8. No, this is 1. This is 1 actually. So this is 1. So what we'll have next is x to the 8th power. We'll not bother with 0 part. This is, where does this one fall? 7, 6, 5, 4. Minus 2x to the 4th power, and then plus 1. So it seems that once we have done with this whole multiplication, the answer is just equals to x to the 8th power minus 2x to the 4th power plus 1. But of course, on a good day, we will not even suffer like this. Here is why. We can easily evaluate this expression using the difference of squares formula. Because here we have, let me write out the number here. Here at one point here we have x to the 4th power minus 2x squared plus 1. We're having to multiply it, we're having to multiply it with still x to the 4th power, but then we have a plus 2x squared plus 1. So it seems that x squared plus 1 is one common term here. And just like those who follow my channel, we like difference of squares formula a lot in this channel. So this one will give us negative 2x squared, and then we'll have x to the 4th plus 1. I'll have a positive 2x squared, and that's calls us for this use of this formula: a minus b times a plus b equals to a squared minus b squared. So this case, a is split by x to the 4th and b is split by 2x squared. So this will become x to the 4th plus 1 squared minus 2x squared all squared. So this is x to the 8th plus 2x to the 4th power plus 1 minus 4x to the 4th power. So that would be x to the 8th power. Let me write it where. That would be x to the 8th power minus 2x to the 4th power plus 1. And I think this is exactly what we got here. If I zoom it out, this is exactly what we got here. This is the same thing we got here. So see that sometimes, even though this method of detached coefficient is very, very nice and good, sometimes we can look for easy ways to make our life easy by applying the difference of squares formula, especially when the terms are nice. So that is all for the video. Thank you for watching, and please subscribe to the channel. Bye.